Hey guys, Hoffbauer here again, hoping to finish up this lovely video week. I don't know. I'm not ready to do 1.5 yet, so this is the last recording for today. We are going to talk about functions and composites of functions. The only thing tricky about any of this really is the domain, and the rules for domain are the same as they always have been. So we're going to talk about operations with functions. We're going to add, subtract, multiply, or divide to form a new function. The domain of that will be everything except, okay, all real numbers except values that make the denominator equal to 0. In other words, for each new function, the domain consists of those values of x common to the domains of f and g. The domain of the quotient function is further restricted by excluding any values that make the denominator 0. So we can have restrictions if there's a square root, just like we talked about earlier. Hoping you remember this, okay? The domain of a variety of functions, polynomials without radicals, are all real numbers. Functions with a fraction or a variable in the denominator, you set the bottom equal to 0 and you exclude that value. Otherwise, the domain's all real numbers. Functions with a variable inside a radical, you set the term inside the radical greater than or equal to 0, and then you solve to find the values that would work. All right, those are the restrictions on domain. Keep those in mind. So operations with functions, just like you can add, subtract, multiply, and divide numbers, you can do the same to functions. When you see this notation like this, it means the same as taking them separately and adding them together. When you see product, it is a dot, not an open circle, and it means you are multiplying them. Subtract means just subtract them as though they were separate. And when you see this symbol with f over g, it's the same as if you wrote them separately, and anything in g that would make a 0 in the denominator has to be excluded. Okay? Sometimes they write without the dot, like this, but it is not the same as the open circle. The open circle means you're putting g into f, and that's called a composition of functions, and that's the second half of this video. All right, so starting out, we have an example. Here's our f function, here's our g function. It says find the function and its domain. We're supposed to add them. This is a parabola, polynomial function with domain all real numbers. This is a line, again, domain all real numbers. When we add them together, we just take all the values, all the expression here we had for f, and we put a plus in the middle, and all the expression we had for g. We combine any like terms, and we end up with x squared minus 4. Again, this is a parabola. There's no restrictions on what we can put in for x. There's no denominator, no square root. So the domain is still all real numbers, okay? The second half of this example, though, talks about f over g. So when we write this function over this function, we cannot have an x value of -2 down here. So our domain has to be x cannot be -2. Now, it just so happens on this one, you can factor the top. Factors x minus 3x plus 2. And the denominator was x plus 2. So this divides out. But if you were to say, I want to graph this divided by this, you would have an undefined place at -2. It would actually be a whole or removable discontinuity. So you have to include that in the domain, okay? Because -2 is not a part of the original f over g, you still have to say it does not exist as part of the domain, even though it reduced out, which won't happen very often. All right, so given this f and this g, we are supposed to subtract for part A. So if we write down the f function, we are supposed to subtract the g function. And I'm putting them in parentheses because you're going to forget, somebody's going to forget that when you subtract, you're distributing that. So we end up with x squared minus 3 minus 3x plus 1. Combine those like terms and put it in standard form, which means exponent power highest to lowest. So we have x squared, a minus 3x, and then the constant term of negative 3 plus 1 is negative 2. All right, this had no restrictions on the domain because there's no denominator, no radical. So the domain is all real numbers. This is a dot, not an open circle, so we are to take f times g, f times g. Now we're not combining like terms, we are distributing here. So x squared times 3x would be 3x cubed. X squared times negative 1 would be negative 1x squared. Negative 3 times 3x is negative 9x. And negative 3 times negative 1 is plus 3. Now, if you did not get this in standard form, you would need to reorder them so that it was in standard form, particularly when you're using delta math. It says write your answer in standard form. So you would need to list them in this order. Okay? And the 1, you could put the 1 in or leave it out. Delta math will count it right either way. All right, there were no denominators or radicals, so the domain is still all real numbers. All right, a few more examples. This time it says we are to add, subtract, multiply, and divide, and state the domain. The only one, oh, nope, I'm wrong already. This one is going to have a domain restriction right off the bat because G has a domain restriction right away. X cannot be 0. All right, but let's go ahead and add them. Would be x squared minus 1 plus 2 over x. And you can leave that in this order for standard form. I don't believe I had any with denominators on the delta math assignment, but if you have an argument that you put something in and it marked it wrong because of standard form, you take a picture and we'll talk about it, but I don't think it's going to be an issue. All right, the only thing x is restricted is it cannot be 0 because we can't divide by 0. So we could say x cannot be 0, or if we were getting all fancy-dancy, we would say in interval notation, it's everything up to 0 but not including 0, and everything from 0 and up but not including 0. All right, for f minus g, we would have x squared minus 1 and then minus the g function. But again, no distributing or anything, and x cannot be 0. I'm not going to rewrite that domain restriction. And then f times g, it's a little messier. We have x squared minus 1 times a 2 over x. I could have written that out in front, but I'm going to distribute it from the back here. So we would have a 2 over x times an x squared, which shows up in the numerator, and then minus a 1 times a 2 over x. So this would be a 2x squared over x, and one of those x's could divide out, so we'd end up with a 2x. And 1 times 2 is just 2, and there's still a denominator of x. Okay. All along, there was a denominator of x, so x cannot be 0. That's it. And then the crazy one, we have f divided by g. So f is x squared minus 1, and we are supposed to divide it by 2 over x. Now, I hope you remember just a little bit of fractions. The numerator divided by the denominator. When you have a fraction, you change it and you multiply by the reciprocal. So now we end up with an x and an x squared minus 1 all in the numerator, and a 2 in the denominator because we flipped this over, and this was over 1. Now there is a little bit of craziness here. You can distribute this and write x cubed minus x all over 2. But the fact remains that at some point in here, x was in the denominator, so the restriction is still x cannot be 0. I'm going to tell you right now on the delta math, I don't think it asks much about domain restrictions, so you're in luck. All right. And I suppose if this was a delta math question, it might ask you to rewrite it like this, but I'm pretty sure I didn't ask one like that. All right, number 2, add, subtract, multiply, and divide. If we add, we just get this mess. And the only restriction, do you remember? When it's under a radical, you have to have a positive number, but it can be 0. Square root of 0 is 0. So we want to say what's under there has to be greater than or equal to 0. So we would have 0 to infinity, and it's just as easy to write that one in interval notation. If we subtract, we just write the x minus the f minus the g of x. And it's the same thing. Underneath the radical has to be 0 or greater. And then we have f times g. And this one's going to look messy, but luckily there's nothing really. We're just going to distribute it to all 3 of those terms. So we get an x squared times the square root of x. We're just going to leave it like that. And a 4x times the square root of x. And then a minus 7 square roots of x. Again, it's under a radical, so it's everything 0 and greater. Then we come to the crazy business of dividing. If we write the f over the g. Now, we're not supposed to have a radical in the denominator, but we're not going to worry about it. We're just going to leave it. Okay, to leave like this. But the domain restriction under a radical has to be positive or 0, but we can't divide by 0. So instead of saying it can be 0 and up, we're going to say it's got to be greater than 0 and up. So changes to a parenthesis because you can't include 0. If you put a 0 in here, you'd have negative 7 over 0, which is undefined. So the restriction changed, but otherwise, again, I didn't ask hard ones on delta math. Oh, all right, part 2 of the lesson already. Composition of functions. Did I miss something on this first part? No, that's all I was supposed to do. Okay. Composition of functions is when you put one into the other. Okay, in a function, composition, the result of one function is used to evaluate a second function. Given functions f and g, the composite f of g, and this little symbol is read f of g, can be described by the equation, and it means you put the g into the f, okay? You work inside out or backwards if you're reading this. This means g is put into f. Another method to combine functions is called composition. Given f and g, the composite is defined as, okay, this is f of g of x, is how that is read. And it means you put g of x into f. Okay? Now, the domain sounds all complicated, but most of the time you just look at your final answer. Okay? The domain of the composite f of g is the domain of G such that G is in the domain of F? Just look at this final answer and evaluate the domain here. After you've stuck one into the other. We're just going to go with that. So, given that f of x is this and g of x is this, we are to find both f of g of x and g of f of x. So this one is putting g into f. So we write out f. So we have 3x squared plus 2x minus 1. And everywhere that there was an x, we're now going to put g into f. This goes in to these 3 spots, or 2 spots. 4x plus 2 and 4x plus 2. Now this one is a bit of an algebraic nightmare for some of you. You need to FOIL this together here. So you get a 16x squared plus an 8x plus another 8x. And 2 times 2 is 4. And then you still have that 3 to distribute. I'll go ahead and distribute back here. So if I distribute here, I get 48x squared plus 24x plus 24x plus 12 plus 8. Can I move myself out of there? 8x plus 4 minus 1. If I combine all those like terms, I could have combined these earlier, but I would get 48, oops, I didn't write that, 48x squared plus, there's 48 x's plus 8 more would be 56 x's, I believe. And there's a 12 plus a 4 is 16 minus 1 is 15. Oh yay, I got their answer. Okay. Whew, that was so fun. We're supposed to do it backwards. We're supposed to put G into F. I'm sorry, F into G. I said that backwards. F into G. So we're going to write G out this time. Much easier. We wrote G out, and now we're supposed to put F inside of there. Yay. If we distribute, we get 12x squared plus 8x minus 4 plus 2, which simplifies to 12x squared plus 8x minus 2 when we combine those like terms at the back. All right, so this was f of g, and this guy over here was, no, this is f of g. And this is g of f, which was putting f into g. Sorry, I just said that backwards. But at the end, there were no radicals and there were no denominators. So for both of these, the domain is simply all real numbers. Okay? See if I can put myself back on the screen here for you. All right. So this time we are to find f of g, g of f, and then we're going to put a 4 in. Now there's 2 ways you can do this. If you've already had to find f of g, you can put the 4 directly in there. But normally when you see this, whoops, I would not do all that work. I would put a 4 into g, and then I would take that answer that you get and put it into F and be done. So let's do that part first on this question, and then we can double check it later. Let's put a 4 into G. So if we put a 4 in here, G of 4 would be 4 squared minus 2 times 4 minus 4 would be 16 minus 8 is 8 minus 4 is 4. So G of 4 gives us a 4. And then we would need to put that into F. This is not a very good example because it's this 4 either way. So we'd have 2 times 4 plus 1, which is 8 plus 1 are 9. So we have f of g of 4 equals 9. And we're going to check that at the end because we're going to plug a 4 into our final evaluation here. All right, let's start with this one. F of g means to put g into f. So we're going to put this mess in here. Well, that's not so bad. 2 times x squared minus 2x minus 4 plus 1. Distributing. Simplifying or adding some like terms. Hope I did that right. I have no denominators or radicals anywhere, so the domain is all real numbers. And that was f of g. So before I do the other one, we're supposed to find f of g of 4. So if I wanted f of g of 4, I could put a 4 into that. Four squared is 16, and then times 2 would be 32. This would be 16 minus 7 is 9. Okay? So if you already had to evaluate f of g, putting the 4 into that evaluated function is pretty easy. But if you didn't have to do that and write all that, you could have just put the 4 into g and then that answer into f. And that's what we did over here. All right, we still need to finish g of f, which is putting f into g. So if we take a g, which said this, and we put in 2x plus 1 and 2x plus 1. A lot of algebra to do here. All right, 2x plus 1 times 2x plus 1, and then we can distribute back here. We get a minus 4x minus 2, and there was a minus 4 on the back. Foiling this together gives us a 4x squared. Inside and outside are both plus 2x. And last times last, 1 times 1 is 1. Now if I combine my like terms in standard form, I have a 4x squared. But look what happens in here. Those cancel out. So I have a 1 minus 2 is negative 1, minus 4 is minus 5. Again, no denominators, no radicals, so if I needed to state the domain, it would be all real numbers. All right, a little more fun here. F of g means g goes into f. So we have 3 something squared minus 4. There's f. We're supposed to put g in there. Well, if you multiply 1 over x times 1 over x, you just get 1 over x squared. And then you're supposed to multiply it by 3, so you would get 3 over x squared. And then there's a minus 4 on the back. What is the only value x cannot be? 0, or if you had to write it out as an interval notation, you would say everything but 0 is good to go. All right, if we are doing GOF, or f into g, this time we're putting all that down there. So g was 1 over x, but our x is now 3x squared minus 4. All right, that's a messy domain. You would say this denominator cannot equal 0, 3x squared cannot equal 4, x squared cannot equal 4/3, x cannot equal plus or minus the square root of 4 over 3, which would be plus or minus 2 over the square root of 3, which if I made you do the rationalization would be plus or minus 2 square roots of 3 over 3. So x cannot equal either of those values. Pretty sure I didn't put that on any test or quiz. Ugh. All right, last thing it wants is f of g of 4. Now, we can put 4 in over here, or I'd like to show you again, it's pretty easy to put 4 into the g and then that whole answer back into f. So if I put 4 into g, I'd have 1/4, and then that answer back into f. Yeah, that's not real fun, is it? 3 times 1/4 squared minus 4. Type that in your calculator if you want. 1/4 times 1/4 is 1/16. Times 3 would be 3/16. Minus 4. If you type that in and do a math enter, you will get -3 and 13/16 or some decimal. I don't even know what that decimal is. Let's type it in here. (3/16) minus 4. There's the decimal. If you do a math enter, it's going to give you an improper fraction of -61/16. Okay. Anyway, all good. One more. I should probably skip this one, but because it is radical, I'll go ahead and do it. The first one, f of g, says put g in here. So you get 4 square roots of x plus 3 minus 2. That's it. Nothing simplifies. But what's underneath the radical has to be greater than or equal to 0. If we subtract 3, we get this. In interval notation, x is greater than or equal to -3 would be -3 and up. So there's our domain. G of f says put f underneath there. So we have a radical, 4x minus 2, and then there's a plus 3. Those parentheses don't mean anything, so we're just going to combine like terms, and we get 4x plus 1 underneath there. Whoops, wrote it backwards. That is g of f. Now, what's underneath the radical must be greater than or equal to 0. If I subtract 1, divide by 4, so I would have -1/4 and up is the domain of that one. All right. Finally, it says find f of g of 4. We can put 4 into g. If we put a 4 in here, we would have square root of 7. And then we're supposed to put that into f. So we're supposed to put that in there, 4 square roots of 7 minus 2. And that is actually the answer. The other option would be, we already found f of g right over here. And we could have put the 4 in here. And we would have got the same thing, 4 square roots of 7 minus 2. All right, you could give a decimal approximation, but there's nothing else to do to that as far as simplifying. All right, quickly, one more. Put g into f. We would have 1 over x squared minus 1 minus another 1, which would be 1 over x squared minus 2. All right, this is a weird one again. The domain restriction is this denominator cannot equal 0. So if we added 2 over the other side and square rooted, we'd get plus or minus the square root of 2. So x cannot equal plus or minus the square root of 2. If I was really cruel, let's see, it would be up to negative square root of 2, and then negative square root of 2 up to positive square root of 2, and together with positive square root of 2 to infinity. Yep, I would never ask that. Look. All right. That was fog. Goff, where you put f into g, you put this mess in here, so you're writing, I have something squared minus 1, and in there I'm supposed to put f. I don't think I really want to mess with this. You would have 1 over x minus 1 quantity squared minus 1. If you FOILed that bottom out, you would get x squared minus 2x plus 1. X minus 1 times x minus 1 will give you that. And there's a minus 1 on the back. I'm going to leave it. We should have to get a common denominator, but I'm not going to mess with it. What is the only value that will give us trouble here is if we put in a 1, this would become 0, and we can't divide by 0, so x cannot equal 1. Last one, I hope anyway, put a 4 into g, and then that answer into f. 4 into g would be 15, and then put that answer into f. Would be 1 over 15 minus 1, or 1/14, which should be the same thing if we put f in here. So put a 4 in here, 1 over 4 squared minus 2, 16 minus 2 is 14, 1 over 14. So either way. Oh, thank goodness. All right, on to one more little concept. I think these are easy peasy, but a little hard to read, so be careful. This says, what is g of 2? Remember, this is an x value. So you are saying put 2 in for x in the g function. Well, it's hard to see, but that one's the g function. If I put in a 2, I get out a -4. Then you would put -4 in for x into the f function. The f function is red over here. If I put a -4 in, what y value do I get out? Appears to be -9. All right, you want to try that one on your own? Put the 5 into h. This is h. So if x is 5, I'm getting out a -6. And then you're supposed to go and plug that answer back into g, which was green here. So if -6 is my x value, into g, my y value comes out to be 4. All right, think about that. Try these 2 more. Maybe pause the video and try these before you listen to me explain it, because I don't think you get a lot out of watching me on these. G of -3, we're on the green one. At -3, right here, we were at +1. And then you're supposed to put that answer into h. And h is this blue one. And if I put a +1 in, it appears to me I get out about a 6. I'm going to say approximately 6, because that one's kind of hard to see. All right, over here, I'm supposed to put the -7 into f. Well, f is this red cubic looking thing. If I put a -7 in there, 5, 6, 7, I'm right here. My y value right there, that's -7, 0. So my y value is 0. So now I'm putting that value into g. And g is this line right here. And I need the x value to be 0. Well, this ordered pair is 0, -2. So there the x is 0 and the output is -2. All right. I might have put one of those on the Delta Math practice because I think they're kind of fun, and it's a good, it's a really important activity for calculus. All right, guys. This is all an assignment on Delta Math on operations and composition of functions. Good luck.